Hello, welcome to Chapter 9, Section 2. We are working in the guided practice problems that are the extra problems right before the homework that's in the back of the section. In the book, it's on page 603, either 604, somewhere it switches over to page 604, and we're going to do problems 13 through 17. So we're going to find the vertex without looking at the graph. We're going to find the vertex from the expression that represents the function. How do I do that? We remember that if I have a graph, it makes a parabola. The vertex is where it changes direction. Now I did this as a opening up downwards parabola. That doesn't matter whether it opens upwards or downwards, same idea. And the axis of symmetry splits that parabola. That's a bad way of saying it, but I think it's kind of descriptive. Splits that parabola into two parts where the left side matches up with the right side. It's symmetric. And where that happens is right here, come on marker, at the vertex, wherever the vertex is. Now we can do all of that with algebra without looking at the geometry. In other words, we can do it with the expressions instead of having to graph it and look at it. So my steps are going to be find the axis of symmetry, and then that'll be the x-axis of the vertex, and then I'm going to find the x-coordinate. I did it again. The x-coordinate of the vertex, and then I'm going to put that number into the expression to get the y-coordinate. All right, so here's how we do this. My a is going to be -5. My b is going to be +10. My c is going to be 3. My axis of symmetry, and I'll write it up here, b divided by -2 times a. So I take 10 divided by -2 times -5. You can do this in your head. -2 times -5 is 10. So in my head, I'm thinking 10 divided by 10. And 10 divided by 10 equals 1. So my axis of symmetry is x equals 1. That means that the x-coordinate of my vertex is that number, because all of the x-coordinates on the axis of symmetry are 1, and the vertex is on that axis of symmetry. So now I'm going to take that 1 and replace it. So you get y equals -5 times 1 to the second power plus 10 times 1 plus 3. Remember, exponents, I know parentheses come first, but parentheses mean do this part. It's a way of grouping. I don't have anything grouping. These parentheses are being used for multiplying. Of course, net 1 to the second power, so it's being used for exponents too. So don't worry about that. But exponents come first, then multiplying, then adding, and remember, subtraction means adding the opposite, so it's all just adding. So I'm going to get -5 times 1, because 1 to the second power equals 1. And everything else I left alone. Now I multiply. -5 times 1 is -5. 10 times 1 is 10, plus 3. And I have 3 numbers that are being added. Doesn't matter which 2 you pick. -5 plus 10 is 5. 5 plus 3 equals 8. Or -5 plus 13 equals 8. Or -5 plus 3 is -2, and -2 plus 10 also equals 8. It doesn't matter which 2 that you pick. So that tells me that my vertex takes and that's y, takes my x value, which is 1, and my y value, which is 8. And again, pause, rewind, do whatever you need to do. Number 14. This tells me that a is 1, b is 4. My c is also -7, but that won't come until later. I get x equals b, which is my 4, divided by -2 times a, which is 1. Now in my head, I'm thinking 4 divided by -2, which equals -2. So my axis of symmetry is x equals -2. That's also the x-coordinate of my vertex. So I take y equals -2 squared plus 4 times -2, subtract 7. take care of the exponent first. Negative 2 to the second power means negative 2 times negative 2, which is positive 4. Now I multiply. I don't have to do anything here or here, but I can do this. I get 4 times negative 2 is negative 8. And I'm going to go ahead and say plus negative 7, because it just makes it easier to understand. Now I will say this, if you're in a pinch and time is an issue, what I did here didn't affect what I did here, so I could have done those at the same time. But again, I'm in explain how to work this mode. I'm not in here's how to get the answer mode. So I'm trying to show you everything step by step. So if you're some random stranger watching this on the internet, you don't know who I am, that's why I'm doing it that way. All right, 4 plus negative 8 is negative 4. Negative 4 plus negative 7 is negative 11. And again, if you do 4 plus negative 15, you still get negative 11. Or if you do negative 3 plus negative 8, you still get negative 11. Either way, my vertex is going to be negative 2, negative 11. I tried to fit all these on the same piece of paper so I could save some paper, but we'll see if I got room. All right. So my A is 1/2. Wonder if that's going to cause a problem. And my B is going to be 2. So remember, I'll write up here x equals B over negative 2A. So my axis symmetry is going to be 2 over negative 2 times 1/2. All right, before you panic and say, I've got a fraction inside my fraction, I have fraction inception, all you gotta do is multiply. Negative times positive is a negative, and 2 times 1/2 is just 1. Half of 2 is 1. So this becomes 2 over negative 1, which gives me x equals negative 2. Now I put y equals 1/2 times negative 2 squared plus 2 times negative 2. And I was worried I'd run out of room here, so I'll try to squeeze it in there. Right? We'll do the exponent. Well, actually, no, I've got exponents and multiplying, so it's okay. I get 1/2 negative 2 times negative 2. Negative 2 squared is positive 4. And 1/2 times 4 is 2, and 2 times negative 2 is negative 4. So my y is going to be, I'll put it right here, negative 2. That means my vertex is negative 2 for the x, and it also happens to be negative 2 for the y. For number 16, I got some room for this one because I got this space over here. A is going to be negative 1, B is going to be 6. And of course C is 1, but we'll get to that. 6 divided by negative 2 times negative 1. This is 6 over positive 2, which equals 3. So my axis symmetry is x equals 3. I take that 3 and I replace it in for the x. So I get negative 3 squared plus 6 times 3 plus 1. Exponents, this is, and by the way, this is not negative 3 times negative 3. This is the opposite of whatever 3 squared is. 3 to the second power is 9, so the opposite of 9 is negative 9. Whether the negative is inside the parentheses like this or outside the parentheses like this is really important. 6 times 3 is 18 plus 1. Now I did the exponents and the multiplying at the same time, but like I said in the previous one, they don't affect each other, so it's okay. Negative 9 plus 18 is positive 9, and positive 9 plus 1 equals 10. And either way, if you want to do 18 plus 1 is 19, and 19 minus 9 is 10, it's all good. My vertex is going to be 3, 10. Now, I was a little confused by why we're doing this last one, because they show you a graph, and I'm like, well, okay, you can find the vertex, it's like right there. But then I thought, well, actually, that's going to be kind of weird, because if it was on one of these passing grid lines, be kind of easy to figure out where it's at, but it's not. So it looks like my x value is -2, but I don't know what my y value is, so I'm going to have to figure that out. I think that what they wanted us to do with this one, without trying to get into Dr. Berger's head, they gave you the equation of the function. Well, actually, it's the expression of the function. I know I gotta stop that with the equations, but they gave you the expression of the function, and you can go through the steps like we did. All right, so a is 1, b is 4. All right, 4 divided by -2 times 1 is going to be -2. But I think that what they want us to do is recognize that I have the axis of symmetry right here, so I know that my axis of symmetry from the graph is going to be x equals -2. So now I'm going to take that x value and put it into my function to see what I got for the y value. I think that's what they wanted. Either way, it's okay. So I get y equals -2 squared plus 4 times -2, I forgot the negative, subtract 5. -2 times -2 is +4. 4 times -2 is -8. And I'll do plus -5 because it makes it easier. So 4 plus -8 is -4, and -4 plus -5 is -9. I think that my y value is -9, and my vertex is going to be -2, -9. Let's see if that works. So notice that this goes by 2. So -2, -4, -6, -8, and about halfway is going to be -9. So it certainly seems like it could be -2, -9. All right, we got one more problem, which is an archery problem. So we'll finish that one up, and then good luck.